Good day, everyone. Today I will be discussing a very important topic in engineering drawing, which is missing view orthographic projection. So, in technical drafting, we often represent three-dimensional objects using 2D drawings. So, these drawings are called orthographic projections, and they usually come in three main views: the front view or elevation, the top view or plan, and lastly, the side view. So these views help us fully understand the shape, measurements, and features of an object. However, in many engineering problems, one view is not given. So our task is to determine, reconstruct, or draw the missing view based on the two views provided. So, understanding how to find a missing view is an important skill because it helps us visualize objects accurately even without seeing all their sides. Introduction to missing view orthographic projection. So, orthographic projection is a method used to convert a 3D objection into flat 2D drawings. So, each view provides different information. The front elevation shows height and width. The plan view shows width and length, and the side view shows height and depth. So when one view is missing, we use the other two to rebuild the shape. So this allows us to understand the complete form of the object even if not all drawings are shown. So there are strategies for determining the missing view. So the first is scanning points, lines, and surfaces. So the first strategy is to carefully scan all the points, lines, edge, and surfaces shown in the two given views. So every line has meaning. So some lines show length, some show height, and some show depth. So by checking where each line begins and ends, we can understand the shape the object is forming. So this step is like reading clues. The information is already there. We just need to interpret it carefully. So the more we study the lines and surfaces, the more accurate our missing view will be. So the second one is exploring object boundaries. So the second strategy is to identify the boundaries or the outer shape of the object. So if we understand the outline from the front view and the outline from the top or side view, we can combine this information to create the missing view. So we have also techniques for visualization. So visualization means imagining the shape in 3D. So this helps us see where edges line up, understand which surfaces appear in the missing view, and transfer correct proportions from one view to another. So the side view explained that the side view shows the object from left or right, so it reveals the object's depth, internal features like cutouts, notches, or protrusions. So these details may not appear in the front view, so the side view is very helpful when completing the missing view. So the third one strategies is understanding views. So breaking down complex shapes. So sometimes the objects looks complicated. So to make the drawing easier, we break it into simple shapes such as cubes, cylinders, wedges, rectangular blocks. So seeing the object or simple parts helps us project those parts correctly into the missing view. So plan view explained. So the plan view is the view from above. So it shows the width and the length of the object. So the overall shape and layout, this helps us understand how the object is arranged and how it connects with the other views. So we have also elevation view. So the elevation or front view shows the object from the front. So it reveals height with contours, vertical measurements. So It is essential because it shows the main features and the structure of the object. We're done in strategies for determining missing views. So this time we will discuss the methods for identifying the missing view. So to find the missing view, we compare the two given views. So we match heights from elevation, widths from elevation or plan, and dips from plan or side view. So by aligning these dimensions, we can accurately reconstruct the missing third view. So this ensures the object stays consistent across all views. These are the key takeaways. So in orthographic projection, shapes like cube, cylinders, webs, and vents are frequently used to represent complex objects. So understanding these basic shapes helps in accurately inferring dimensions and relationships in the missing view based on the provided projection. So accurate projection is crucial to precise engineering designs, ensuring clarity and functionality in construction and manufacturing process. So, mistakes in deriving missing views can lead to costly errors and operational efficiencies. In conclusion, understanding how to determine a missing view in orthographic projection is an essential skill in engineering drawing. So, it requires careful observation, visualization, and the ability to interpret lines and shapes from different perspectives. So, by analyzing the given views, whether front, top, or side, we can reconstruct the complete form of a 3D object accurately. So these skills allows designers, engineers, and students like us to communicate ideas clearly and avoid errors in a real world application. So that's all. Thank you for listening, and that's the end of my report. So this is Diceren B. Abenasa.